Good morning, students. So now we are going to see this experiment, measurement of energy using single phase energy meter for a load. Okay, so this is the energy meter. So this is an olden type of energy meter which you could have seen in your home, but now it has been replaced by digital meters. Okay, so this energy meter measures the energy. So the unit of energy measured is kilowatt hour. So it is also called as kilowatt hour meter. Okay, you can see it is kilowatt hour meter, and this is a single phase energy meter. Since it is single phase, it requires only two wire, a line and a neutral. Okay, so and this energy meter, you can see a value called as 2400 revolution per kilowatt hour. This is the constant of this energy meter, which is used for our calculation. And you can see a aluminum disc inside this. So this disc, you can see a black line, that is a reference. So and this consists of a red color indication. Sorry. So now you can see a red color indication in that aluminum disc. So this indication is what we are going to use as a reference for measuring our energy. Okay. So this energy meter is connected to the fuse. Okay. To give the input, okay, to protect the overcurrent, we have a fuse here, and this energy meter is going to measure your load energy. So here the load used is a rheostat load, lamp loading rheostat, which is a kind of a resistive load. So since it is a resistive load, so this energy consumed will be very high. So you can see this load. This is your incandescent lamp, which have a resistive property, and it is made up of a tungsten filament. Okay, so you know that this lamp, since it is a resistive load, it is not going to store energy. It will dissipate the energy in the form of heat. So large amount of energy will be consumed by this type of loads. So as we increase this load, you can observe the meter will be running fast as I increase the amount of load. So what we are going to do in our experiment is that we are going to measure the number of revolutions taking that reference line. We are going to measure the number of revolutions and the time taken for making that revolution. So for our calculation, let us assume a simple number of revolutions as 5. So for every 5 revolution, what is the amount of time taken? So measuring that, we will get the actual energy which will be consumed by that load. Okay. So you can do that calculation using the formula which is given in your manual. So I am just going to show the demo of this experiment, how to measure that energy, how your energy meter works, and how it behaves as you increase the load. So before that, let's see the connection. So this is the connection. So this is our input, and this is the input, that is your main supply, and this is your supply for your energy meter, and from energy meter we will be providing it to the load. Okay, so this Pn is the input to the energy meter, which is given from the input of the supply P and N. Okay, phase neutral has been connected. Then this is a load terminal, so I connect this load terminal of energy meter with the load. Okay, so this is P will be connected with your P of your load, phase of your load, and N will be connected with the N of your load, that is neutral. So the load is connected to single phase supply. Okay, so now I just switch on. You can observe that this energy meter is running. We have made 1 revolution, 2 revolution. So like this you can take for minimum of 5 number of revolutions. We have to measure the time taken for this number of revolution. Okay, and we have to use this constant value 2400 to measure our actual power, actual energy consumed by the load. Okay, so that you can do it referring the formula from your manual. So now you can, I am going to increase my load. So initially I have switched on one lamp. So this lamp is of 200 watts. Okay, so I am going to switch on another 200 watts load. So 400. Now you can see the meter runs quite faster compared to the previous case. This is because as we have increased the load, the amount of energy consumed will be larger. Okay, so now I have increased the load further. You can see the disc is rotating faster. Okay, so like this we can increase the instance of load. So here we use 200 watts lamp. So we also have 100 watts lamp. So I can go with 100 watts, 200 watts, and step by step we have to increase the load and measure the time taken for 5 revolutions. And using the formula given in your manual, you can calculate the energy, actual energy consumed by your load. Okay, thank you.